Okay, looks like I left off on number 43, so let's see what's next. Number 45. So I just need to write the complex conjugate of the number and then multiply by it. So actually it looks like I didn't quite finish number 43. I wrote the complex conjugate, but I didn't multiply through by it. So I'm just going to use FOIL. So 4 times 4 is 16, minus 3i times 4 is 12i, plus 12i, and then minus 9i squared. So these guys cancel, and 16, and then minus 9, and then I squared is negative 1. So minus 9 times negative 1 is plus 9. So I get 25 for that one. So your goal, and you'll notice whenever you multiply two conjugates together, all of the imaginary components will cancel out. And if that doesn't happen, then you know you've made a mistake and you need to go back. So negative 6 times negative 6, positive 36. And then you'll always notice I've got negative 6i radical 5. I always write the I before the radical, by the way. Negative 5 times negative 6 is negative radical 5 times negative 6 is positive 6i radical 5. So again, when we multiply conjugates, our middle terms will cancel, and it's probably going to happen where I will stop writing that all the way out. So now negative times positive is minus. Radical 5 times radical 5 is 5i squared. So 36i squared is negative 1, so that's plus 5 equals 41. Number 47 is next. So it's the square root of negative 20. So first thing, I am going to write that out as a simplified number. So I'm going to take the I and put it outside of the radical 20. Then I'm going to simplify my radical 20, which is 4 times 5. And the square root of 4 is 2, so I could pull that out. So I'm going to call that 2i radical 5. Then the conjugate is negative 2i radical 5. So positive times negative is negative. 2 times 2 is 4. I times I is negative 1. Radical 5 times radical 5 is 5. So that equals positive 20. Number 51. So now we need to get this quotient in standard form. It's 6 over I. And the way we do that is we multiply by the conjugate. So I can sort of think of this as 0 plus I, and then 0 minus I is the conjugate. So I get negative 6i over negative I squared, which is negative negative 1, which is 1. So in number 53, we have 2 over 4 minus 5i. So by multiplying by the conjugate, we're just going to be allowed to follow that rule where there's no i's allowed in the denominator. So I'll go ahead and do the denominator first. 4 times 4 is 16, and then I'm just going to show minus 20i plus 20i cancels out, and then minus 5 times minus 5 is minus 25i squared, or plus 25. Then we've got 8 plus 10i on top, and I can simplify a little further and call that 41. Number 55, we have 2 plus I over 2 minus I times 2 plus I over over 2 plus I. So let's multiply the bottom first. We've got 4 minus 2i plus 2i, and then minus I squared. So 4 minus minus 1 is 5. And then I'll multiply the top out. I've got 4 plus 2i plus 2i, that's plus 4i, plus I squared. So that's negative 1, so that's going to be 3 plus 4i over 5. Number 57. I've got I divided by 4 minus 5i squared. And let me think how to handle that. Thinking I should probably expand this out first and then figure out what the conjugate is. So 4 minus 5i squared, I'll just write it like this so that I can show you guys what I'm doing. So 4 times 4 is 16, minus 20i, so that's actually minus 40i, and then minus 25i squared is plus 25. So that's 41 minus 40i. So the conjugate of this thing is actually 41 plus 40i. So I definitely needed to expand that out before dealing with it. So on the top we get 41i plus 40i squared, so I'm going to have to deal with that. Then down here I've got 41 squared, which is, I'm using my calculator, 41 squared is 1,681, and then minus and plus, and then minus 40 times positive 40 is minus 1,600i squared. So let me rewrite this up top. I've got negative 40 plus 41i over 1681 plus 1600, 3,281. So it's a lot. That looks a lot different from where we started. All right, last one, 61. Let's see what the directions are. So this is an addition of fractions problem, which we've been practicing a little bit. I'm going to leave some space so I can show where I'm probably going to have to multiply some stuff to get a common denominator. Let's see. 3 plus 8i. So now I'm going to combine these two expressions to make my common denominator. So I'm going to multiply by 3 plus 8i over here on top and bottom, 3 minus 2i over here on top and bottom. So I really just have a bunch of imaginary number FOIL problems to deal with. So let's go ahead and see what our new denominator is going to be, and then I'll have it in both places. So 3 times 3 is 9, plus 24i, minus 6i, minus 18i squared, which is plus 18. So let me just come down one more layer and just clean that up a little bit. 9 and 18 is 27 plus 18i, and so that's going to be my denominator over here as well. And now I times 3 is 3i, I times 8i is 8i squared, plus 8i squared is minus 8. And then 2i times 3 is 6i, minus 2 times 2 minus 4i squared is plus 4. So now we remember the rule for adding fractions, 27 plus 18i, and add the numerators. So I'm going to combine 3i and 6i and get 9i. And down here, negative 8 plus 4 is negative 4. So I was thinking I might need to factor out a 9 somewhere, and I could factor one out on the bottom if I really, well, if I was taking a multiple choice test and this answer wasn't on there, I might go looking for this. But that doesn't really help me reduce anything on the top, so that's not absolutely necessary. So that's it for 2-4.